Good day everyone. Today I would like to discuss the topic of goodness of fit, which is known as R square. The term of goodness of fit is usually used in discussing the result of economic model that is involving ordinary least square, or known as OLS estimation. So this topic is we're going to learn about the definition of R square or goodness of fit, and we learn about the concept as well, the concept of R square. After that, we're going to discuss about the component of R square, which is residual sum of square and total sum of square. After that, we're going to learn how to calculate R square in our estimation model by using a simple data analysis, data series. So let's go to the definition first. Let's say we have two types of data, which are first observed data and actual data. So we consider the variation of data is inside the red circle, and another type of data is estimated data, which is represented by estimated y equation. We can see like this, and the variation of estimated is inside the blue circle. So you can see the blue circle and the red circle overlap each other, which the overlapped area can represent how fit estimated y in order to explain the actual data of y. Thus, goodness of fit indicate how effective the estimated model in explaining the variation of observed dependent variable. It means that the larger estimated y area overlap with observed y, the better our model in explaining the variation of observed y. So here I provide some elaboration on the concept of the goodness of fit. Let's consider we have two data series, which are expenditure as dependent variable, which or y, and income as independent variable, or we can say is a x variable. Then we plot these two variable where we plot expenditure data against income data. So after that, we use the estimated data in order to create a linear line across the plotted data. So we can see here there are huge and small gap between the plotted data and the linear line. So if we zoom in the data in the gap, we can see the difference between estimated y and observed y, or actual y. Therefore, to get the better model of economic model, so we aim to minimize the gap between estimated y and observed y, which reflect our estimation is good enough to explain the variation of the actual data. So there are two components in explaining the concept of R square. First is a residual sum of square, where the formula is the summation of square difference between actual y or with the estimated y. We can see like this here. And then we go to other concept of R square, which is total sum of square. Okay, we back to the plotted data. Back to the plotted data, we consider there are the mean value of y, which is constant. So the constant value will create the horizontal line across the graph. Okay, like this. And then we notice that there are gap between the mean value and the actual y. So it create, from this difference we create the formula of total sum of square, where the difference between actual y and the average y will be square, which in turn will be the product of difference will be sum. Okay, then we will get these two value, which is residual sum of square and total sum of square. We put into the formula of R square in order to measure the fitness of how fit our model into the actual dependent variable. So here I provide some example by using two data series which are income as a dependent variable and expenditure as dependent variable, or can we say y variable. Then I estimate the result, where the estimation is shown as following equation, and I get the equation. I utilize the equation in order to generate the estimated expenditure, or y hat, or estimated y. Therefore, I have two types of y, which are observed expenditure and estimated expenditure. I use this data to calculate the residual sum of square and total sum of square, which is shown in the calculation that is represented as following. So the value of R square is 0.968, and if I plot the data based on the actual y and estimated y, so the graph will be like this, where the blue dot represents the scatter plot of actual expenditure, while the red line indicate the estimated value of expenditure. We see that the blue dot almost fit with the red line, which is consistent with the value of R square that we calculated before this. So in terms of interpretation, we can say about 96.8% the estimated model explain the variation in expenditure variable. Okay, I hope this can help you in interpret your data of R square. So that's all. Thank you for watching.